A static excitation system is a method used in large synchronous generators to provide the necessary direct current to the rotor field windings without using moving parts like a rotating exciter machine. Instead, it utilizes power electronics, specifically thyristor-based rectifiers, to control the magnetic flux of the generator. In massive power plants, the traditional rotary exciter is removed and field current is supplied straight from a regulated rectifier unit, which draws power from the stator output via a step-down transformer. The maximum potential limit needed for the rotor windings is determined by the specific winding ratio of this supply transformer. The primary benefit of this solid-state approach is its ability to reach any targeted field voltage almost immediately. Furthermore, by reversing the process into inverter mode, the magnetic field can be collapsed with extreme speed. The four main components of a static excitation system are the Thyristor Converter, regulation and pulse electronics, field breaker and field suppression, Excitation Transformer. This component transforms the AC voltage, sourced from the alternator output, into a manageable DC supply. Often called a power converter, it offers these key capabilities. Swift field reduction is possible by simply flipping the excitation voltage polarity. Non-stop reliability is ensured because the system utilizes multiple backup converter units. Large safety margins exist during standard operation, as the specific thyristors are chosen to handle severe electrical faults without failing. Regulation and pulse electronics. This unit generates a command signal based on the gap between the target voltage and the actual reading. Using this command, a pulse generator sends timed triggers to the thyristors to match the regulator's output. It offers these specific features. Customized settings ensure the voltage regulator matches the generator's behavior perfectly, preventing any unstable power wobbles or surges. Balanced grid connection is maintained by adjusting to reactive current changes, allowing the unit to work smoothly with the main power network. Safety boundary controls allow the machine to run closer to its maximum limits safely, maximizing its work time before protective shutdowns are needed. A built-in stabilizer actively dampens power fluctuations and allows the generator to run safely even when its magnetic field is kept very low. Hand-operated backup allows engineers to keep the system running during emergencies and serves as a vital tool for testing and routine maintenance. Field breaker and field suppression essential unit handles the de-excitation process. Its primary duties are to quickly drain excess magnetic energy whenever it becomes necessary, fully isolate the generator's spinning rotor circuit from the power source. Key functional characteristics include automatically toggling the rotor path from the main supply to a discharge resistor, instantly killing the machine's magnetic field during severe nearby grid electrical faults, shielding the delicate rotor windings from potentially damaging high-voltage power spikes. Excitation Transformer unit steps down the incoming power to the precise level needed for the excitation system. It offers these functional features. Its internal electrical resistance naturally slows down sudden current surges, keeping the connected thyristors operating within safe limits. The final part is brush gear. The brush bracket, which encloses the slip ring and carries the plug-in brush units, is mounted on an intermediate plate, which is adjustable in height. Field current from the exciter is fed to the brush bracket through current bars, flows through plug-in brush units and flexible brush connections to the brushes, and from there to the slip rings. The current then flows through flexible connections to lead-in studs and onto lead bars in the shaft bore. Cooling air is drawn in at the cooling air inlet, a cross air filter. The self-lubricating brushes are seated in flat, spiral spring brush holders, which produce uniform pressure through the entire wear zone. The brushes can be monitored, taken out and replaced through covers, installed laterally and above the brush gear. That brings us to the end of gas turbine major components. On the next topic, we will be discussing about generator and excitation fundamentals. Thank you for your watching and see you then.